All right, today I'm going to speak to you a little bit about sustainability. And I know that in Mexico that this is maybe just an emerging topic, a newer topic that you are beginning to hear about. And perhaps on some of your projects, you may be hearing about LEED requirements, and you may be getting questions about some of your materials that you're specifying and whether they have sustainable attributes. So this is going to be a very basic presentation to get you up to speed on some sustainability basics, and then give you some information that if your customers are asking for information about sustainability of roofing products or other products, that you can begin to answer those questions. So as I mentioned, we're going to begin with some basic sustainability concepts. I am going to focus mostly on embodied carbon. If you don't know what that is yet, that's okay. But we'll go over it. But it is the topic that most people seem to focus on right now. So I'll speak a little bit more about embodied carbon specifically. And then how you can use environmental product declarations to answer some of these questions. All right, now if we start at the very high level, sustainability actually has concepts related to environmental impacts, our impacts on society, and then as well economic impacts. So typically when people talk about sustainability, they're only talking about environmental impacts. But 30 or 40 years ago, when sustainability first came to the forefront, the focus was that we really need to keep all of these concepts in the front of our mind, because if you can't afford to do a project, or if you have to inconvenience the public so much in order to reduce your environmental impact, then it's really not sustainable. The definition that usually gets passed around related to sustainable development comes from an intergovernmental panel report that was published in 1987. So yes, 40 years ago almost. And sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And so the important thing to notice is, related to this definition, is that we need to, it's basic concepts related to conserving resources, making sure that we're not using up everything on the earth. And sustainability can apply, it can be used as an adjective to many different things. You've heard of sustainable manufacturing, sustainable design, sustainable buildings. And why are we, though, focusing on buildings so much? The truth is that buildings do impact the environment overwhelmingly when it comes to the amount of energy that we use globally. So the use of our buildings uses about 36% of global energy use, and it's also related to that energy use also contributes to our global greenhouse gas emissions. In the US, 40% of the energy usage goes to buildings. Our buildings also use a lot of water, and certainly in some areas of the world, water is a very scarce resource. And so the fact that, almost 14% of all potable water is used by buildings is something that we should be mindful of. And we also consume a lot of raw materials, and we generate a lot of construction waste during our buildings, using our buildings. So this is just another graphic to show the impact of the global carbon dioxide emissions attributable to buildings. And you can see that 28% of our operations and energy usage excuse me, 28% of our greenhouse gas emissions are attributed to the energy use during our building operations, and another 11% or so is attributed to the materials that we use in our buildings. And so that's where we get the 39% of the greenhouse gas emissions. Other emissions are attributed to other industries and, of course, the transportation sector. When we speak specifically about environmental impacts, one of the concepts that is important to understand at a high level is life cycle assessment. You may have already heard of life cycle costing. So this is very frequently used by customers that are maybe owning their buildings and using them for a long period of time. And so that's when you're using financial choices into our initial costs and then our maintenance and replacement costs. Life cycle assessment is similar to that, except instead of using dollars, we're talking about environmental impacts. And so it's a method that we use to quantify the environmental impact of the choices that we're making and the products that we're choosing. We perform a life cycle assessment in order to develop an environmental product declaration. So for any type of product, whether it's an asphalt shingle, and that's the example that I'm going to use today, or any other water barrier or any other material that we may use on the building, our fenestration, our windows, we can develop an environmental product declaration for those products that is a snapshot of their environmental impact. And related to that is product category rule, and those are the additional rules that we use for a certain category of products, so maybe all roofing membranes or all insulation types will have a product category rule, which helps ensure that the EPDs we develop in a given product category are developed relatively the same, so that they have the ability to be compared. Now, we've already talked a little bit about why we are focusing on embodied carbon, although you may not have realized that that is what I've been talking about thus far. When we do these life cycle assessments, we typically look at 5 environmental impact categories. They are up on the screen here. So acidification, what is the potential for creating acid rain? Eutrophication, what are the runoff from our farm fields that might cause algae blooms in our freshwater sources? Ozone depletion, that is pretty self-explanatory, as is smog formation. So those 4 categories are also evaluated every time we do an LCA and develop an EPD. But the one we're focusing on is the global warming potential. And that is where you're going to find your embodied carbon. So there are a few definitions out there for embodied carbon. They mainly have to do with summing up or adding up all of the greenhouse gases that are generated and emitted due to a certain product. And so it's either this ISO definition here, which is related to greenhouse gas reporting, which has to do with the emissions and removals, because some products do absorb greenhouse gases while they're in service or during production. And we're looking at just that single impact of climate change or global warming potential. The other way to look at embodied carbon, and this is from a structural engineering document that's out, is it's the carbon dioxide related to all parts of your production process for a product, from the extraction and processing of raw materials, transportation of those materials to your manufacturing facility, any greenhouse gases that are emitted related to use and maintenance, and then at the end of life. When we talk about life cycle assessment, we typically we break our product or our building life cycle into these life cycle stages. And so, starting with the letter A, any modules that begin with the letter A occur prior to the building being occupied or getting your certificate of occupancy. So it's production of all the raw materials in A1 through A3, and then transportation of those raw materials or products to the job site in A4. A5 captures all the greenhouse gas emissions that occur on the construction site. And then once we get to the letter B, that is our use stage. And hopefully that is the longest in terms of time period. That's the longest time period on this continuum. And so that's where we categorize any of the greenhouse gases that are due to replacement and maintenance schedules. And then finally, anything that begins with the letter C, that is at the end of life. And so if you go to the end of life when considering your impacts, that would be what are your impacts related to demolition, recycling, transport to recycling facility or a landfill. Okay, so we already talked, at a high level about what environmental product declarations are. They are developed according to an ISO standard 21930. This is the ISO standard that we use typically in North America for developing EPDs. It gives us the rules for how to perform our LCA, and how to report our results in an EPD for all different types of building and civil engineering works products. As I mentioned already, also, the product category rules are typically developed by industry trade groups for a specific type of product. So there are PCRs for insulation. There are PCRs for different types of windows. There are PCRs for different types of claddings. And so the PCRs are what makes sure or helps ensure that if two different manufacturers develop an EPD for the same type of product, that the methodology behind the scenes to develop that was basically the same. So what they tell us in the PCR is that for those unique types of products, they decide things like how long do we assume the service life is, or what types of data should we be using in the background, so that we're really minimizing the differences between how two individuals could develop an LCA or an APD, to minimize the differences that are due to choices that LCA practitioner makes, such that the differences reported in EPD are more likely to be due to true differences in the environmental impact of a product. So an important thing to note about EPDs is that they are just a summary of a full assessment or a full model that has been created by an LCA. It's typically what we're using right now in order to report our embodied carbon data. But it's very important to know that because of the importance in the product category rules or the PCR, when someone is trying to compare two EPDs, it's very, very important that the EPDs were developed using the same baseline PCR, which is, you can think of it like a standard for how to develop the EPDs. Those need to be the same in order to even begin to think about comparing. So frequently what will happen is, an example that I like to give is that, for concrete, I'm going to switch topics. We're off roofing for a second. For concrete, You know, there's a difference between concrete that's cast in situ or in place versus concrete that's prefabricated in a facility. But sometimes when, let's pick on architects. Let's say an architect says, oh, concrete is concrete. And so I want to compare this beam that's prefabricated versus a beam that was cast in place on the site. Well, EPDs for those two products were developed using two different product category rules. They have two very different scopes, and so you really should not be comparing them. So that's the true of all different types of products. You need to make sure that the PCR is the same and not compare across product categories. All right, so when we're doing our analyses for embodied carbon, and here I'm going to go through an example using asphalt shingles as an example. So when we're collecting data in order to develop an EPD for an asphalt shingle, when we think back to those different modules that we're collecting data, the A1 is our raw material sources. So you're collecting data for all the different components that go into making that asphalt shingle. So you're going to have the asphalt, you're going to have sand, you might have some mineral stabilizers, you might have granules, you might have lots of other things that go into scrim that goes into creating that asphalt shingle. You also have energy. You have a lot, you may have natural gas used in your facility, you likely have electricity coming into your manufacturing facility. Some of those energy sources and all of your raw materials are going to be transported to the asphalt shingle manufacturing facility. So A2 is where we capture all of the impacts related to transport of those raw materials to our manufacturing facility. And then A3 captures any of the environmental impacts that occur due to the actual manufacturing process. And this would be considered a cradle to gate scope. Most EPDs only have this scope right now. So this is our scope. You can see our system boundary has the dotted line. And then what happens when we do our mass balance of the system boundary, we're checking that all the materials coming in A1 are going out of the facility either as product or as waste. When we talk specifically about embodied carbon, usually what's happening is that when we have all these different input materials, such as the asphalt and the sand and the granules, those products also have an upstream manufacturing process. It may be for the sand, it may just be, a quarry that those materials are being dug out of the ground, but that uses energy. For the asphalt, that's a much more, the asphalt binder, that's a much more complicated production process. And so, but there's energy related to that. And then, so there's energy in all these different phases that occur that are used as you go through the process. And so that energy, if it is not a renewable energy source, if it's a fossil fuel based source, when we use that energy and burn that energy in order to do all of these things, that releases greenhouse gas emissions into the atmosphere. And so that's really what we're trying to capture in this process. So for the most part, it can be summed up for any manufacturing process. Your embodied carbon is basically going to be the greenhouse gases that are released due to energy use in all the stages. Plus, there are a few chemical reactions that occur for certain products that also release greenhouse gases. So those all get summed up, and that becomes your embodied carbon. If you are a product manufacturer and you have to supply data in order to develop an EPD, don't be too worried about what you don't really have to understand greenhouse gases and LCA and all of that too much. You, as a manufacturer, what the LCA practitioner is going to collect from you is stuff that you are already tracking. And you're already tracking because you pay for it. So you are purchasing quantities of raw materials, you're purchasing quantities of energy, and the only thing that you may not realize is maybe the distance that those materials are coming from, whether it's a distribution facility or the primary manufacturing facility for each of these upstream materials. So if you're a manufacturer, you're looking to develop an EPD, you would provide to the LCA practitioner your annual 12 months worth of quantities purchased, and they do all the work of converting all of that into environmental impacts. What comes out on the other side is your environmental product declaration. So if you are a contractor, if you are a consultant, if you are a product manufacturer, and someone asks you for embodied carbon data, you will look to an EPD to provide that for them. And in every EPD, they may look a tiny bit different. Each EPD is probably somewhere between 4 and 8 pages, roughly. It's not too long of a document. And somewhere in that document, there's going to be a table that looks something like this. And what you're going to look for is you're going to look for global warming potential. It may say climate change, but probably not. If you're looking for it in North America, we typically use global warming potential as the indicator that is our embodied carbon. And so the other thing you want to look for, just in case you're double checking, look for the units. So global warming potential or greenhouse gases are reported in units of kilograms of carbon dioxide equivalents. So what they do is they take all of the greenhouse gases that we're tracking and we equate them into an equivalent of carbon dioxide. So even if the impact category name is slightly different, if you look for the units of kilograms of CO2e, that's always going to tell you that's embodied carbon. In this particular EPD, they do report out more life cycle stages than just the cradle to gate. So if we were talking about just cradle to gate, then we would be talking about just these life cycle modules, A1 through A3. In this case, they actually did report out for the construction impacts as well as the end-of-life impacts. That's not super common. It's becoming more common, but it's not super common right now. Usually you will see the total greenhouse gas emissions aggregated or summed or added together for A1 through A3. You may also see them broken out so that it's A1 plus A2 plus A3 that you would need to add up. But this is where you're going to find every EPD has a table just like this. So you just need to look for that kilograms of CO2e in order to find out what the embodied carbon is. You also just want to make a mental note of how it's reported. So in this case, the units are reported per square meter of applied product. That sometimes can vary. It's almost always a mass or volume or area reporting unit. Okay, so just a little bit more information on EPDs. So this is one that I just pulled off the internet. Most of the EPDs, the great thing about them, in addition to being third-party verified, and so they're you have that greater assurance that the data reported is accurate. They're also required to be posted publicly. So there are databases that publish all EPDs. There are program operator websites that publish EPDs. Most manufacturers will publish EPDs if they have them to their website, or you just have to call your local rep and they'll send it to you, PDF. So a few things you just want to note. The top line there shows you which standards that they conform to. And as I mentioned, almost always it's going to be ISO 21930. Some European companies also generate their EPDs according to an EN standard, a European standard. That one's called 15804, 15804. So you may see that that's in there. I'm only bringing that up because occasionally in the specifications, they may say which standard that you're supposed to conform to. The EPD owner is almost always published on the front page. It's typical for an industry average EPD to be developed by a trade association. So in this case, it's a single ply roofing industry association because it's an average for their entire industry. And then the product name or what products that it's covering is also included. The validation date, most EPDs are valid for 5 years. They have to be renewed after 5 years. Some manufacturers are doing that a little bit more frequently because of the fact that, you know, if they make improvements to their manufacturing process, they want that reflected in their data. And so they may publish more frequently than 5 years, but you have to publish, they're only valid for 5 years. All right, again, this is another page. So typically there's a cover page on the EPD, that's what I showed on the last slide. Then there is a second page that has all this declaration information in it. And this is just to show you that when you're reading your specifications, it may say certain things, like it may say what the product name has to be. There may be an ASTM standard referenced. There may be other information that you will find in the EPD. You just need to look for it because it's not always in the exact same place. But as I said, they're not that long of documents, so it's usually pretty easy to see. There are a few program operators in North America. ASTM is one of them. And so you will see the program operator. They are the ones that administer the product category rules and also ensure that the EPDs are verified appropriately. So they're kind of your third-party QC check that's making sure that the data in these EPDs is valid. An important thing to note is you will always see the PCR that's referenced. So you will see the ISO standard and or the European standard reference, as well as the subcategory PCR. So you can see that there's a PCR for single ply roofing membranes. So if you're ever comparing a couple of products, you need to make sure that they conform to the same PCR. It also shows you which life cycle stages or modules are included in the EPD. So this is showing you that only these 3 modules, this is the minimum that has to be reported. So this is a cradle to gate EPD. It will show you which modules have been reported. This is also important because this is the minimum, as we saw a few slides ago, some product manufacturers are now moving towards including additional life cycle stages. So you can imagine if you're comparing those 2 products, their numbers are likely going to be different, but it's maybe not because one is better or worse. It's maybe because one is just including more information. And then this shows where the modules are reported separately. So they report the A1, the A2, and the A3 separately, but then they also add it up in the last column there. So you also want to make sure that when you're looking, that you're looking at the total when you're looking at different products. And this also breaks it down by the different types of products that are included in the CPD. Okay, so we did cover kind of a lot in a short amount of time. I am here for the next 2 days. So if you have any questions, of course we have time for questions, but I would be very happy to answer those. I know that it's important to understand some basic sustainability stuff, but it's also more important to be able to answer your customers' questions. And so when they get to the point, and if they start instituting the lead rating system here, or some owners are requesting EPDs, it's important that we are able to say, let me check on that and I'll get back to you. Now, I don't know what you're talking about. So hopefully I've given you enough to say, let me check on that and get back to you. Muchas gracias.